All right, vocabulary related to circles to begin with. Remember that word locus, which was like a collection of points? Okay, here it popped up again. A circle is the locus of points in a plane that are a fixed distance from a point that's called the center of the circle. So think about how you draw a circle with your compass. The point is that given point, that's where the pointer compass goes. Your pencil is drawing or marking all the points that are the same distance from that center point. We do have a symbol for circle. I usually don't put that big of a dot, but circle A would be how you would name the circle, named by its center point. Radius is just from the center to the circle. So the radius is AB's length. So segment AB is a radius. And the diameter's length is CD all the way across. So the diameter would be segment CD. If a radius goes just from the center to the circle and the diameter goes all the way across the circle, what's the relationship in their lengths? The radius is half of the diameter, correct? The diameter is twice the radius. So you'll be doing some going back and forth between those different measurements. Got definitions down? Pi is defined by, as we talked about on Pi Day, the distance around the circle divided by the distance across the circle. The distance across the circle is diameter, distance around it is circumference, like perimeter. So this is where they came up with the value of pi. Pi is just defined to be circumference divided by diameter. And I'm sure one of the mathematicians that someone's researching either this class or fourth period came up with the value of pi in a fraction or in a decimal. It gets more and more exact as we get more technology that can do that. But that definition is really where a couple formulas come from. If we take this definition of pi and just multiply each side by d, that would get rid of the fraction, and we come up with one of the formulas for circumference. Circumference is diameter times pi. That's one formula you'll find in the circumference part. Diameter, a little while ago you said, is twice the radius. So if we replace that, we come up with a second formula for circumference. And that's probably the one I use more often. Circumference is 2 times the radius. But if you want to learn that circumference is pi times diameter, that's the very same formula. I have put both of them on the wall, so you could use whichever one you like. I like to use the one with radius because the area formula has radius. So if I use the circumference with radius, then I don't get so mixed up. How do we get that area formula? By taking a circle, if you would cut it into pie-shaped pieces and arrange them, half of them pointing down, half of them pointing up, you form what's close to a parallelogram. If you make it into more pieces, it's not as curved, so it maybe is closer to a parallelogram. The area of that parallelogram is going to be the same as there in the circle. How wide? What's the base of that parallelogram? It was half of the way around a circle. If the whole circumference is 2 pi r, then half of that was just pi r. So the base of the parallelogram I've pictured is pi r. The height of the parallelogram, think where that comes from the circle. Isn't that the radius? So the height is the radius. If I find the area of that parallelogram, I would take pi r for the base times r for the height, and that's where the familiar formula pi r squared would come from. So again, I'd like to show you where that formula comes from. Not that you have to reproduce it, but it makes maybe a little bit more sense why it's that formula. It's not just something someone made up, it actually does have a purpose to it. So those two formulas, the circumference and the area, should be in your notes there. Circle, if the diameter is d and the radius is r, circumference is either pi times diameter or pi times twice the radius, and the area is pi times r squared. Is twice the radius the same as r squared? No. The only number it is the same is if the radius is 2. 2 times 2 and 2 squared is the same. That's the only time they would be the same. Otherwise, if your radius is like 10, 2 times pi times r is 20 times pi, whereas pi times 10 squared is 100 pi, so they are different numbers. We're going to leave a lot of answers in terms of pi because that's actually more exact than going to decimal. If Mr. Williams and I can figure out why it's distorting this way, my circles don't look like circles because it's pulling in funny on this projector. Find the area of circle K in terms of pi. So we don't even need a calculator for keeping it in terms of pi. Formula would be area equals pi r squared. Put in the radius of, how much? Is the 6 the radius or diameter? It's the diameter, correct. So the radius is going to be half of that. So the radius is 3. So pi times 3 squared is 9 pi, correct. So I'm looking for an answer of just 9 pi square inches. That's what it means leave it in terms of pi. That's more accurate than if you really did the decimal down with it. All right, let's try a pizza making kit. We've got 3 circular baking stones. The diameters are up there. Find the area of each stone. Now this one does say round to the nearest 10. Hopefully you got a calculator handy to help you multiply with pi. To the nearest tenth, find the areas. Say, I hope you're taking the diameters and dividing it in half to the radius. R multiplying by pi. I believe most all of your calculators would have a pi button on them. If you Ever have a calculator without it? What's the decimal you're going to use? You would want to use at least 3.14. And if you could go further, who were my Pi Day winners? You remember it at all? Any further?
She's so, she knows so much. Yeah, I knows them so. Yeah, came along, and then Haley just keeps going. She's like, I missed this one, then I go over and 500.
Yeah, yeah, there was one that she skipped, but she had quite a
Yeah,
few.
she had like a lot of them.
Okay, ready to check these answers? Okay, the first one, we use a radius of 12. So you took 144 times pi. In decimal, that was about 452.4. Square centimeters, we're finding areas, so you're squaring it. And then the next one had 1017.9, and the last one was 1809.6 square centimeters. Now I want to show you something that we will be studying in a section, but since we've got this, notice the 24 centimeter and the 48, that diameter doubled. Did the area double? The first one to the last one? Notice it didn't. How many times bigger did it get? You can divide it backwards. You can divide this 1800 something by 452. It got 4 times bigger by doubling the radius. Why does it get 4 times bigger? Well, radius or diameter is going to change the width of the circle and the height of the circle. And both of those have to be considered when you do area. So if you multiply it by 2 this way, and then you multiply it by 2 up and down, that's going to be multiplying by 4 the space that it covers. We'll get to that. Okay, find the circumference and area of circle M if the diameter is 10x. What happens if we throw the variable in there? 10x is the diameter. What's the area and what's the circumference? It's going to have the variable in it. What's the radius if 10x is the diameter? That's half of that. This one does not say to go to the nearest tenth, so that would imply keeping it in terms of pi. So you really don't have to do a lot of calculation. I think you didn't do the squaring right. Did you take 5x times 5x? Oh, good. Yeah, you did the squaring right. Okay, radius would have been 5x, so the circumference would either be 10x times pi or 2 times pi times 5x, which still will be 10x pi. And I don't really care what order. If you go 10 pi x, that's the same thing as 10x pi. Circumference would be labeled just straight units, so that was just feet. In the area part on the right-hand side, we have to take 5x and square it. 5x times 5x is 25x squared times pi. And again, whatever order you're comfortable with, doesn't really matter. So the variable shouldn't cause too many problems. Let's go backwards. Find the radius of circle J if the circumference is 64 pi. Said on the go backwards yesterday, start with the formula. So start with the formula for circumference of a circle. Fill in the C in the formula with 64 pi. You want to eliminate things so that you have radius or diameter, depending which formula you're using. And you can divide each side by pi. That will actually eliminate the pi symbol. You probably would also divide each side by 2. I divided by both at the same time. I got 32 for the radius. The M is the label used. Yeah, and when you're looking at it, you're mentally thinking, I'm dividing the pi's out, and so that number is the diameter. So yes, what you're thinking is fine. All right. Find the circumference of the circle in terms of pi if the area of the circle is 144 pi. So now you're going from area to come up with circumference. To do that, you probably have to either figure out the radius or the diameter. What formula should you start with? Probably start with the area. Figure out what the radius is, then find the circumference. See, what if you get the radius is 12, which is correct. Now find the circumference. Notice I really don't need negative 12 because radius is not going to be a negative. Right? Think what your label would be on those answers. You start with the wrong formula. You will. Yeah. So you understand why you start with the area one and then go to the circumference one? Because this 144, it wasn't the circumference, it was the area. So that involved more steps. You had to go area, find the radius, and then find the circumference back from that. Okay, let's go to, I guess a reminder, wait until the last step when you round. Don't hit the pi button until the end of a problem. Let's go to the regular polygons next. This is a formula that you probably haven't seen before. What's a regular polygon? All sides equal, all angles equal. So it's nice, symmetrical. Again, my projector is distorting these a bit. As far as vocabulary, center of a regular polygon. That would be the point that is equidistant from the vertices. So you need to do some definitions. The center of a regular polygon. So there would be a center point that would be the same distance to every vertex. We kind of did that with the triangle chapter where we were finding the circumcenter that was equidistant from all vertices. Then the term apothome. We will need the apothome when we find area of a regular polygon. So what is the apothome? It says it's the distance from the center perpendicular to a side of the regular polygon. So distance is always measured perpendicular. That's why I put it in parentheses. But if you go from the center point to the side, forming a right angle, that red segment is the apothome. And I know it looks distorted here, but to every side will be the same length. Are the blue segments the same length as the red segments? Now, how can you decide without just guessing? Well, think about what shapes formed. The red segment's perpendicular, go over, and the blue one, we're forming right triangles. Isn't the hypotenuse always longer in the right triangle? So the blue segments are longer than the red segments are. So it's not the same length. If you would connect the ends of the blue segments, you would make that circle that went on the outside. Do you remember what kind of a circle we said that was? When it went on the outside. Came from a circumcenter, circumscribed circle. Circumscribed circle went on the outside, and then on the inside, maybe, yeah, that was maybe easier, in center, so this was an inscribed circle. So there are two circles we could visualize again related to that. Okay, so center and apothem. I have to figure out how this screen can look the right way. All right, so then there's a central angle in that regular polygon. We talked about what the center is. If you're forming the angle then from the center to consecutive vertices, you create a central angle. That angle is important for us to figure out how many degrees it is. On a regular polygon, when you draw those central angles, how many will there be? Yeah, it's going to be the same as the number of sides. So how many sides did I have here? I think 8. So in this octagon, got to remember the names of those shapes again. Was it octagon or maybe decagon? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, decagon. I was thinking I drew an octagon. Decagon, 10 angles. How many degrees is each of those central angles? What should they all total? 360 degrees. They will all be the same in a regular polygon, so 360 divided in this case by 10 would make 36 degrees for every central angle. What if it had 8 sides instead of the 10 that's up here? How many degrees would each central angle be if it's in an octagon? What would you divide 360 by? 8. 360 divided by 8 is 45 degrees. What if it has 20 sides? How big would each central angle be? What did you do to figure it out? 360 divided by 20, 18 would be correct. Okay. So my little formula here for each central angle, that's what you're doing. To get each central angle, you're taking 360 degrees and dividing by the number of central angles, which is the same as the number of sides. Now, why is that important? Okay, to find the area of a regular polygon, we're going to find the area of each of these triangles in our picture. We're going to find the area of every triangle and total it, add it all together. All of the triangles are the same when it's actually visually regular. So how will we find the area of one of them? How do you do a triangle's area? 1/2 times base times height. So 1/2 of this edge times the height, which is called, look at your notes, what's that called? Apothem. Okay. So if you took 1/2 times the side times the apothem, that would give you one of these triangles area. How many of those triangles do I have? In this case, 10. It would be the same as the number of sides. So if I took the area of each triangle times the number of triangles or number of sides, that would be one way to find the area of the whole regular polygon. Now, we do simplify that just a little bit, because if we know how long each side is, and we know how many sides there are, what do we get when we multiply the number of sides times how long every side is? What would that be called? I'll give you the distance around it. Perimeter. So instead of the separate side times the number of sides, in our simplified formula, we'll just replace that with perimeter. So the formula you're going to be finding is 1/2 times the apothem times the perimeter. I'll go to my screen that has that. But that makes sense how we're getting it. We're finding the area of every triangle and multiplying. So if you get stuck, find the area of every triangle. Total it. That's what you'll do to get the area. This is what I was just explaining. And the screen that has the formula right there. So the area of a regular polygon. It has to be regular, otherwise all those triangles are not the same. A regular polygon. If the apothem is A and P is the perimeter, we just take 1/2 times the apothem times the perimeter. That takes care of the area of each of those triangles totaled up. Understand the formula? Let's do an example and then do some harder ones. So here's kind of a straightforward example. Find the area of a regular hexagon with a side length of 5 centimeters and an apothem of 4.3 centimeters. So the nearest tenth in the end. So formula, area is 1/2 times the apothem times the perimeter. Hexagon, is that what he's asking?
Yeah.
How many sides? 6. I don't remember what chapter that was that we did the polygon names, but 6 is hexagon. 5 is pentagon, 7 was heptagon, 8 was octagon, nonagon, decagon. So yeah, how do you get the perimeter? 5 for each side times 6 for the number of sides. So 6 sides are all 5, so 30 should be the perimeter. 1/2 times 4.3 times 30 is 64.5 square centimeters. Give me a thumbs up if you did that one right. All right, any certain question? Okay. Find the area of a regular dodecagon. That's my 11. Well, undecagon or undecagon, that was 11. A dodecagon is 12. All right, so find the area of a regular dodecagon with side length 5 centimeters to the nearest 10. What is the perimeter? 12 times 5, right? What's the apothem? I didn't tell you, did I? Okay, so we got to figure out how to find it. Dodecagon has 12 sides. I'm not going to draw a complete 12-sided figure up here because I probably wouldn't do it correctly. So I'll just draw a few and leave it open. Okay, so the side length is 5. Let's think back to that central angle. This is a dodecagon. How many degrees is that central angle? Figure it by doing what? 360 divided by 12, which would be 30 degrees. That's the central angle. Now, I want to find the apothem. So I'm going to look for a way to find this perpendicular length. We've been solving right triangles a lot. We should be able to work with it if we know some information. What do we know about that triangle? Well, this whole side was 5. When we put a perpendicular in that kind of isosceles triangle, it always cuts it in half. So instead of 5, now we have 2.5 for that little piece. This angle, the 30 degrees was the whole central angle. But now in my triangle, it's not 30 degrees. It is half of that, 15 degrees. And I'm trying to find the apothem. We did that type last chapter. Okay, trig ratios. Opposite and adjacent would be tangent. So tangent of 15 degrees, number 1, would equal 2.5, which is opposite, over apothem, which is adjacent. And I cross multiply. I have to divide by the tangent of 15. Now, how accurate do you go? Well, the more accurate, the better. A standard that I'm using is hundredths. And then a lot of the problems say tenths at the end. If it says tenths, you don't do tenths through the whole problem. You do more decimal and then estimate at the end, or round it off at the end. So I would be going 2 decimal places here. What's 25 divided by the tangent of 15? 9.33? 9.33? That's the apothem. So now you should be able to finish your area. So to find your area, you were doing 1/2 times 9.33 times 60. And that was found by taking 12 times 5. So your area is 279.9 square centimeters. Can I switch the screen? Just get rid of my writing and show my printed part. So we had to work with that little right triangle in order to get the apothem figured out, and then we could finish the problem. So that one was missing the apothem. There will be some that are missing maybe the side length, because so that you can't do the perimeter. So you should be able to find a side length or an apothem. Sometimes they'll give you that distance that goes to the corner. They'll call it the radius rather than the apothem, like the blue instead of the red that I had earlier. So we'll have to see what information is given. Question on that one before I go to another one? Okay, let's find the area of a regular octagon with a radius length of 4. I think you can probably draw an octagon, but make it kind of big so that you can write some things in there. Draw yourself an octagon, regular octagon. Stop sign if you don't know what that shape really looks like. Not perfect, but good enough for reference, probably. Okay, what do we need to, let's see, the radius length of 4. So from the center, that's not the apothem. They're saying to this corner, that length would be 4. Like the radius of your circumscribed circle, that's 4. We know it has 8 sides, but we can't figure the perimeter or the apothem right now. What was something we started with in our last problem? We had to find the central angle. How many degrees is the central angle? central angle. Okay, then when we want the apothem, we're going to divide it. So the angle that we're using now will be half of 45, 22.5. But you need to find the apothem, and you need to find this little length so that you can get the whole side figured out. So work on the apothem and that little length. If you want to have this in your notes, make sure you're thinking about that as you're working it instead of doing it all in the marker board. It'd be good to have something to look at. Cross multiply. So let's do 4 times the cosine of 22.5. So you don't have to do this dividing. Just 4 times. It was your apothem 3.70. Apothem would have been cosine of 22.5 being a over 4. They say 3.70. And how'd you find x? Do another trig ratio or Pythagorean theorem? Trig ratio, okay, you could do either one probably. If you're doing a trig ratio, probably opposite and hypotenuse, cosine. You could use tangent, but you're going to be using something we already rounded, so maybe that's not the best choice. Okay, so what does that little piece, I guess it's not the apothem, what does that little piece end up being to 2 decimal places? 1.53? Okay, so if that's 1.53, that means the side is double that, 2.06, which makes the perimeter 24.48. Okay, which makes the area now 1/2 times the apothem times the perimeter. And which say it comes out? 45.3? Okay, that sounds right then. 45.3 square centimeters. Anybody get there before I finished it? Question on what I did? Make sense? Okay, so that one, I didn't give you the apothem or the perimeter information, so you had to find quite a bit. The last one you had to just find the apothem. Well, let's see. These are usually the ones that students have questions on, so what else do I need to show you? All right, so we did the circle, we did the circumference. I want to make sure you get to work on some of these regular polygons in class. So So I think I'll go ahead and stop here so that you can do some of these on your homework assignment. All right. Let me shut that off a second. And not that it's a long assignment,